This is Geometry 3.6D. We're talking about angle pair relationships, day 4. So here we're talking more about proofs. How do these geometry proofs work? Remember, we don't start by trying to fill out the actual proof. We focus in on the given. We look at what we're trying to prove. We're going to prove that lines are parallel. To do that, recall, we need to come up with one of these situations. We need to show corresponding angles are congruent, or alternate interior angles are congruent, or alternate exterior angles are congruent. We could even show consecutive interior angles are supplementary. If we have this, then we'll have parallel lines. And of course, if we have parallel lines, then we know that we would have this. But we don't know we have parallel lines P and R parallel. We know that G and H is parallel. So we're looking for one of these types of angles. We also know that angle 1 and angle 2 are congruent. So you're supposed to try to come up with a reason why P is parallel to R without filling out the proof. Just use your own words using this information up here. Pause the video, think about that, and then come on and we'll finish it up. So what we're recognizing is that G is parallel to H. Now, when I see lines are parallel, I know I'm supposed to look for one of these. The pair that I see that are touching my parallel lines are 1 and 3. They're the only angles touching G and H. Angle 1 and 3. They are called corresponding angles. I know if the lines are parallel, then corresponding angles are congruent. So I know that angle 1 and angle 3 have to be the same measure. I also know that 3 and 4 are congruent because they're vertical angles. So 3 and 4 have to be the same also. I wish I knew that 4 and 2 were congruent. If 4 and 2 are congruent, then I would know my lines were parallel because alternate interior angles would be congruent. Well, in the given information, they say that 1 and 2 are congruent. 3 is congruent to 1. 3 is congruent to 4. So 1 is congruent to 4. One is also congruent to 2. So 4 is congruent to 2. Hey, we did it. 4 is congruent to 2. So you are trying to come up with your own explanation on why the lines are parallel. And you're starting to realize that for the lines to be parallel, you need one of these to happen. Which of these do you have? Alternate interior angles. And we just showed they were congruent. You just saw how the path works. Now you can come and start talking about filling out your proof. G is parallel to H. That's our given information. Some people think that they put all the given information all up front. And sometimes we do. But notice here, they're waiting for more given information later on. So let's not talk about this given information yet. Let's just talk about that given information. Because the lines are parallel, we know that corresponding angles are congruent. If lines are parallel, then corresponding angles congruent. Could you write that without looking for the boxes? Did you fill that in without studying the boxes? That seems very reasonable. You could do that without the boxes. If two angles are vertical, then they are congruent. I wonder which angles I'm going to talk about. Can you decide that without looking at the boxes? Can you decide that by looking at your picture? Where's your vertical angles? What were you trying to accomplish? 3 and 4 have to be congruent. And they are vertical angles. Vertical angles are in the picture. They're going to be congruent right now. If comes earlier, then comes right now. Angle 1 is congruent to angle 4. Angle 1 is congruent to 3. 3 is congruent to 4. So 1 is congruent to 4. 1 is congruent to 4. What is that called? Can you come up with that statement without using the boxes? This is how you practice not having boxes. Transitive, POC. Now notice your proof has more given. That's a hint that you might put a second piece of given information down here. We haven't even used the fact that 1 is congruent to 2 yet. You could have had it in the very beginning, but since they wrote it down here, the given, what they're trying to show you is the parallel took us all the way to here. Now we need more information to be able to proceed, because 1 is congruent to 4 and 1 is congruent to 2. They're giving us a hint to use transitive property. Can you guess, without looking at the boxes, what numbers would go in here? Right, angle 2 and angle 4 are congruent. That's the transitive property. And to be parallel, there's only 4 different correct answers for that parallel. So one of our 4 ways is going to be alternate interior angles. We finally showed that 2 and 4 were congruent. 2 and 4 are not corresponding, are not alternate exterior or consecutive interior. They're alternate opposite sides of the transversal, both interior. If alternate interior angles are congruent, that's what we had before, right here. If comes earlier, then comes right now. Then the lines are parallel. Use this idea that if comes earlier, then comes now. Look back up at number 2. If would have been parallel lines, then would have been angles. Down here, if would have been angles, then would have been the parallel lines, because of how it's written. Good job, we did it. Let's come on down to the next one. Before you do your proof, come up with a plan. Talk to the person next to you. Explain it to yourself if you're by yourself. Ray ED is perpendicular to ray EF. That's all we know. Why are angles 7 and 8 complementary? This is a very reasonable one. Why are 7 and 8 complementary if these 2 rays are perpendicular? Come up with a plan, discuss it so you can explain it. Then we'll worry about filling out the proof. Pause the video. So let's see what we think. We have ray perpendicular to ray. The 2 rays are perpendicular to each other. I know that rays that are perpendicular means right angle. They're going to make a right angle. And I know right angles make 90 degrees. And I know that 7 and 8 make this big angle. So 7 and 8 are 90 degrees. So if 7 and 8 are 90 degrees, then 7 and 8 are complementary. It was pretty straightforward. Perpendicular makes right angles. Right angles means 90 degrees. 90 degrees is complementary. Two angles that add up to 90 degrees. So we would always start with our given, and there's only one bit of given information here. So that's our perpendicular. We know the two sides are perpendicular. Oh, look at that. We have a right angle, DEF. How do we know we have a right angle? This is an if-then. If what, then what? If we have rays that are perpendicular, so here's a little shortcut, if perpendicular, then it forms right angles. Well, we can say then right angle, and you did it without just copying a box. I didn't even read the boxes. If came earlier, then is happening right now. Look at the if-then statement. It's exactly what's in your proof. If comes earlier, then comes right now. How do we know we have 90 degrees? Where did 90 degrees come from? I know that DEF is a right angle. DEF is a right angle, but why is DEF equal to 90 degrees?
Right angles equal 90 degrees.
So if comes earlier, if right angle, then 90 degrees. Then is happening right now. If you have an angle that is a right angle, then its measure is 90 degrees. You can use all those words, or you can just shorten it up. If right angle, then 90 degrees. So next we have angle addition postulate. I don't like their abbreviation of addition, but whatnot. Angle addition postulate. What are they talking about? Well, think about it. Where are we trying to go from here? Sometimes people get confused with proofs, but you've got to focus on where you're trying to get to. You're trying to show 7 and 8 are complementary. We haven't even talked about 7 and 8 yet. Where is 7 and 8? 7 and 8 are in our picture. 7 is this little angle. 8 is this little angle. Angle addition postulate, that might be a way to bring 7 and 8 onto our proof. So the measure of angle 7 plus the measure of angle 8 equals the measure of angle DEF. Small angle plus small angle equals big angle. That is angle addition postulate. The substitution part is because DEF is 90 degrees. A lot of people like to skip that, and they like to go right to the 90. But that's the substitution. Understand that angle addition postulate is just the names of the angles. Then we can substitute in information we know, and because they equal 90, if two angles add to 90, then they are complementary. Take a look at that. If comes earlier, then is coming right now. If, then. So you know what's going to be at the end of your statement. You knew most likely what's going to come on the beginning. If doesn't have to come one step ahead. Sometimes it comes several steps ahead. But in this proof, it worked out really smooth. It was one step ahead each time. There it is. You did your proof. We didn't have to study boxes. We didn't put the puzzle together just by reading what seemed to be appropriate. You figured it out on your own. And we're done. That was our 2 examples. Good job, everybody.